Human milk is amazing. It is a baby's first meal and it provides all of the essential nourishing ingredients a baby needs to survive and thrive. We've all heard the phrase, breast is best, and mothers in recent years are much more aware of the benefits of breastfeeding. However, the inconvenient truth about breastfeeding is that breasts are invariably attached to a person. A mother who may be too unwell after giving birth to breastfeed, or who may have to return to work within a few weeks of giving birth. A mother who may not be able to get their newborn to latch on, or in some cases may simply not produce enough milk. For these reasons and many more, mothers who would love to breastfeed simply cannot. So although it is true that breast milk is the gold standard in infant nutrition, it is still vital that we aim to develop infant formula which mimics the functions of breast milk in as far as possible. One solution for narrowing the gap between infant formula and breast milk is the inclusion of breast milk sugars known as HMO. Now, HMO are the third largest component in breast milk ahead of fats and proteins. And as you can see here, they constitute over 16% of a baby's daily ingested solids. But remarkably, they are indigestible to the infant. And as a breast milk component, they are not there to feed the baby at all. So why are they present in breast milk and in such large quantities? Well, it turns out that instead, HMO act as a food for the bacteria in the infant gut. My project focused on investigating how good bacteria, specifically clinically proven probiotics isolated from the infant gut, interact with these breast milk sugars. I used human intestinal cell lines and sophisticated omics technologies to assess whether HMO isolated from breast milk could improve the growth, colonization, and protective effects of these probiotic strains. I found that these HMOs not only significantly increased the growth of these probiotic strains, but also helped them attach or adhere to the intestinal cell lining in significant numbers. I identified the genes, proteins, and enzymes involved in these interactions, and in doing so have advanced the state of the art in HMO research by providing an in-depth understanding of the crosstalk that occurs between bacteria and their human host. The payoff from this project is twofold. Firstly, my findings will help guide the development of targeted, personalised HMO-containing probiotic products for infant nutritional companies. And secondly, and perhaps more importantly, findings from HMO research have served and will continue to serve as yet another compelling motive to encourage and support breastfeeding globally.